All right, let's look at this question. We have a circular pipe that is cut so that the length of the cut, so this is the cut right here, the yellow line here that represents a cross section of the pipe, which is circular, and this length is equivalent to the radius of the pipe, the radius of the cross section, circular cross section. The question is that if the maximum height of the cut pipe is 2 meters, so from the maximum height to the actual top of the cross section is 2 meters, so I just showed it with a dotted line, and that's 2m for 2 meters. What is the radius of the pipe, which is actually the cross section, right? In the cross section of the pipe. So let's look at this question and let's draw what we need. First thing is to label what we can using this diagram. So I've got this center, the red center right there, which it was there, but it's not there anymore. But here we go. That's the center. So what we're going to do is that we're going to draw the radius. So we're going to straight go up and hit the cross section cut. And also we know that this length, the radius, is also from the center. So we know that this is our radius. We know that this length from here to here, the red portion of the radius, it is part of the entire radius. So be aware that this entire thing, so from here all the way to the top, is actually the radius. So the way we write it is the radius minus 2 will give us this part right there. All right, we already have this part right there, that's the radius, and we know that's a 90-degree angle because part of the Euclidean geometry is that you have a radius and you have a chord. They cut at 90 degrees if the actual radius goes through the center of the chord, and we can assume that because it is a cross section of a circle. And now the other part is the yellow part, and since it cuts that cross section, the cut in half, we can easily say that this part right here is half of r, so as this part is half of the radius in terms of measurements. All right, we have Pythagorean here to deal with. Basically, we have this triangle A, B, and C, and then we can write up the Pythagorean equation and then solve. So what do we have? We have r squared equals to, that's the hypotenuse squared, is equal to r minus 2 squared plus half of r all squared. Excellent. So now we're going to expand. We have r squared on the left hand side. This becomes r squared minus 4r plus 4 plus, and that becomes a quarter of r squared. All right, when we simplify this, the r squared minus r squared, that's 0, okay? And then what we have, I'm going to rewrite this using the descending order of the polynomial, so that becomes 1/4 r squared minus 4r plus 4r. And because we got this chord in front, we're going to multiply everything by 4. Just going to make a note here. I'm going to multiply everything by 4. And the new equation will be 0 equals to r squared minus 16r plus 16. Okay, so we're going to use quadratic formula because this is not factorable, this quadratic equation. And when you use the quadratic formula, just remember that there are two possible answers. And the quadratic formula says minus b plus or minus b squared minus 4ac all over 2a, given the fact that the coefficients of r squared is 1, that's a. b is minus 16, that coefficient of r, the middle term, minus 16, negative 16, and c is the constant 16. We plug the numbers in. What we will get, here's what we will get. The two answers, possible answers, will be, the first radius will be 1.07 meters. The second one will be 14.928 meters, or approximately 14.93. So notice that R1 at 1.078, this value right here, that doesn't make sense, since this portion of the, if you look at the diagram again, this portion, the BC portion of this triangle, which is part of the cross section, is R minus 2. Well, if you actually plug in 1.07, let's just do that, 1.07, just rounding it to 2 decimal places, and then you do, that's the R, then you have to do minus 2, that will give you a negative answer, negative measurements. Okay, so the negative measurement doesn't make sense in this context, so therefore the R value has to be 14.928. That is our value, and that's the answer to this question. Okay.